Okay, this is Algebra 2, Unit 1, and lesson number 9. So the question here is, what's the equation? So more practice problem on writing down the nth formula, or also called explicit formula. So the focus will be on writing explicit formula or see how it changes uh, depending on the step function. So let me dive down straight away to the first problem. And I want you to first is you can pause the video for a while and see if you can answer it yourself. So there's a party with a hexagonal table placed together with space for one person on each side. So what does that mean is, uh, suppose there's only a single, let's see if there was just a one table like this, okay, just a single table. So this does not look good. So let me graph a nice one, draw a good one. So, so here, then, so this is the hexagon. So that's the hexagon. And you can clearly see hexagon has got six-sided. So naturally one person will sit here and another chair, another. So these are like chairs, six chairs. So that's why this is six. And then when you add another one here, right here, see. So what's going on here is the middle part. This is nobody can sit at this place on right or left. So those two will be gone. So even though this together will be 12, but then these two are taken off, so there will be only 10 chairs left for two tables. But if I want to put another one, and you can see there is a plus 10 here, which is the rate of change is 10. So you add the third table. So if you add third table, then what's going to happen is there will be this two gone. So there is a 2 gone, together 4 is gone from 12, 12, 12 is, sorry, 6, 6, 6 is 18. In other words, you get 14 because from 18 I'll have to take left, right, left, right. These are the four has to be taken off and so on. So then you can see clearly there is always increasing uh, each time four chairs are added. Describe how the number of people who can sit at the table changes. So each step, so when you go each step, you can say the number of number of people sitting down increases by four. That's all it is. So D equals 4, which is the rate of change, and it is also uh, called common difference, okay, and that's what we learned here. Next is explain, can we write P of, what does P of 32 means? So far what we got here is the first one is P of 1. That means if there was one table, the number of people sitting down, so P stands for number of people. And if there are two tables, then it means if there are two tables it is 10, and if it is one table it is 6. So this will be P of 3, which will be 14. Then this will be P of, I want you to really, really understand this, P of 4, and that's 18. So that means you can't have a 3 point. What does this 3? So the number, so this, you can have only 1, 2, 3, 4, 5. You cannot have in between because either you can have only one table or two tables. So there, you can't have 1.5 table. That doesn't make sense, right? So that's all you're explaining here. Why it doesn't make sense? Because you can't have 1.5 table because only possible, you can't cut the table into two pieces. It's just either one table or two tables. And the last question is asked is what is the recursive definition? And this I've been, in my lesson number 7, I've been going so many examples I went through, and I think that should help. So this part basically it means, one second. So, okay, so recursive, what is recursive? The definition, let me write the definition part is, because this is arithmetic sequence, if you see on the chart, A1, you should know the very first one. This means the very first number, the first number in the step one. So you have to mention that. So this lowercase usually I use for, or you can just write A1 is given, no, whatever that, and any number at nth position is always the one before n minus 1 and plus d. So all you do here is this one is 6 here, so you are going to put this is 6, so a1 is 6, and then you say okay, instead of plus d, you're taking off plus d, and you write minus, sorry, you add plus 4. But remember, you need to write n greater than either 2, 3, 3, 4, like that way, or you just write greater than equal to 2 and you're done. So this is all you're supposed to write this part. This is the recursive definition. And if we want to write the explicit formula, we can write that too also. And how to write explicit formula, check the charts. And the charts clearly shows is the formula is a and is equals. Starts the first one, a is the first one, and plus, and the rate of change which is d, and then you have to write n minus 1. Now this formula is to be used only when the table, this number starts with 1. So right now it is 1, so I'm going to write here. So the population is started with p, so it is p of n is, in the beginning you had 6, so that's the a, that's the 6, a is 6, and plus, and the d is the 4, this is the rate of change which is 4, and n minus 1, and then you say okay, n greater than equal to 1. So this is how you're supposed to write, and not greater than equal to 2, because for the recursive is what you're writing now. You could also write this whole thing, this you're done with this nth term or explicit formula, or you could also write Pn is 6 plus 4n. You can write, but then you have to say okay, equal to 0, and you get the same thing. Look at this. So it's like if you make a step with 0 like this, and then that's 6, right? 1, 2, and so on, become 10, 14, and you can see start with 6, and then n is, if I put 0, it's only 6 days. If it is 1, then you add 4, and likewise you get your sequence back. And let's go to the second question. In the second question, there's a student. What he does is he's making a stack of pennies, right? So let's say this is like a 1 penny, and then you put another one, and like that. So what he does, he starts with the 5 of them. So it's like 1, 2, to see 1, 2, 3, 4, and 5, and this is together is 1.5. So this is 1.52 mm. So that means when you have a table, it starts, and then he adds them. Oh, sorry, each penny is 1.52. So it is 1.52, and because he's stacking 5, so you have to multiply. And if you multiply 5 times 2 is 0, 155, 25, and you have 6, 1 stay, 5 on the, so you get 7.6, and it's correct. See? So that means, so 5 of them is 7.6. And after that, you going and adding 1, 2, and so on, right? So when you add 1 to it, and since each of this is, so this d is the common difference, which is the rate of change is 1.52. So you're just adding 1.52. So 7.6 plus 1.52, you get 2, 1, 8, 9.12. So this is 9.12. And likewise, I want you to really do it yourself instead of me showing. But my goal is to understand, complete the table. So this is what you're going to complete. And what does h is the height. Now what is h stands for? H, and it stands for it is the height of the stack of pennies. So it is the stack of pennies of n pennies. So that is, n can be 5, 6, 7, and so on. And remember that it starts with 0. That means 0 is what, 7.6. That's the start. So I want you to write two things. You can't have a penny with 1.52. You can have only h of 1, h of 2, h of 3. I can't cut a penny into two parts. It has to be only one. And that's why this does not make sense. And if I want to write the recursive definition here, and I want you to really want you to write this on your paper, and this is nth equation or nth term or nth equation. So how will we write? And again, I repeat this time we have height, right? So recursive means height of n pennies is always, you have to see what is the height of the previous n minus 1. So this basically means the one before, h n minus 1. And then you are adding 1.52. And this is for n greater than equal to 1. Here I have to write 1 because h of 0 is given. H of 0 is 7.6. And you're done. This is recursive definition. And to find the n term, because it starts with 0, see, if it starts with 0, then your formula changes. So h of n is, the first one is 7.6, 7.6, and then you're multiplying 1.5 to n minus 1. Now this, I could use this only if this started with 1, but because it did not start with 1, I'm not going to use this. I'm not going to use this, but I'm going to write 7.6 plus 1.5 2 times n, and n is greater than equal to 0, and you're done. So this is how you write the nth equation, or it is also called explicit formula. Okay, so let's go to the problem number 3 is slightly different. This is the same example we are using. A paper has 80 square inches. So if this is 80, then there is a person who cuts off 1/4 of the piece. That means I can split this into 4 pieces. See, ah, so and these are 4 pieces, 1, 2, 3, 4. So what he does, he person cuts off 1/4 of the piece. That means this is taken off, right? So if this is 80, and 80 we can split as 20, 20, 20, 20, right? So one of them is gone. So what is remaining is 3 20s are remaining. So 1/4 is gone. That means so other 3/4 is remaining. So 3/4 is remaining. I want you to get this part. So it means, what is this? 20 is gone, means from 80, the 1/4 of 80 is over. So, and 1/4 of 80 is 20, clearly common sense. So what stays is 20, 20, 20. So there are 3 parts of the 4 parts. So it is 3/4 is remaining of the 80. So when you are writing down the answer, in the beginning we had 80. 1/4 means 20 is gone. So 3/4 is remaining. It means this 20, this 20, this 20 together is 60. So this is remaining 60. And then you can clearly see, because you are taking off 1/4, so 3/4 of the whole thing is remaining. So this 60 which I write is basically, it is 3/4 of 80. And clearly this can be written as 80 divided by 4. We can use our common sense and you get the same answer, 60, right? And then again, so next is again this piece is left, right? These are like okay, so let me put it like this, this part. So these 3 are remaining. So I'll take off the bottom part, this part. I don't. So this is 3, 4. This was 60 together. Now again, this is divided into, let's say, 3 parts, like 3 parts, and maybe this one, this one. This is 1/3. It's like the whole thing is broken into 1, 2, and 3 pieces. So the 60 is split as, we can, 60 is can split at again. Uh, I think I made a mistake. Let me draw this visuals again. That means what I left it is this one, okay? This one. So this is what was left. So I have to divide this again into 4 parts, not the thing. So I have to divide this into, maybe, I don't know how I'm going to do this part. 1, maybe 2, and so this is like 60 can be split into 15, 15. So this is our common sense. So 15, 15, 15, and 15. So one of the 15 is taken off. So this is gone. So what I will be remaining is 15 plus 15 plus 15 is 45. So this answer is 45. But I wanted to think of that, okay, so let me write again. So this is 3/4. Now remember, this is the growth factor is 3/4 of 80. Now again, what's going on is you are multiplying 3/4 of 60. This was 3/4 of 80. So this is the algebraic way of organizing 3/4 of. You can see 3/4 of 60 is 3 times 60 over 44, which is 3 times 15, and you get 45. There you go. So that's how you are working on this problem. So we understood the growth factor, which is R here, is 3/4 here, which is also called a common ratio. What's the question is you are supposed to complete the table, and that's what we did, and you're supposed to do the next one yourself and cut off. What is the nth term? So now we can write the nth term. So how do I write the nth? Remember, this starts with 0 here. N starts with 0. So the question is either I have to write A, that is the area, is the in the beginning that you have A, whatever that is, and then R raised to n minus 1. This is n greater than equal to 1. Or if it starts with 0, then you do the same in the beginning at 80. That's the main thing. And every time you multiply 3/4, 3/4. See? So how many 3/4 are you multiplying is, if it is 0, then you just write n and you say n greater than equal to 0. And now the answer. So how do we write the answer is you write A and area of the piece of paper after n times. So when you do cut it 4 times, so in the beginning it was 0. See, when you divided one into 4 parts and you take off one part, so 60 remaining, then again you divide it into 4 and then took off 1/4, so 3/4 of that again. So that's what that means is A of n is you had area of the piece of paper in the beginning, and then every time you took 3/4 of whatever that is remaining. So how many times we have to do this is n, and we say n greater than equal to this completes the end. And what is a reasonable kind of domain here? So how long can you go on doing this? If you see go on doing with your calculator, I wanted to show with the desmos.com, but I wanted to figure out it yourself. Figure out on the calculator maybe and find what is A of 1. So on the calculator, you can do A of maybe 5 and say, okay, 80 times 3/4 of 5 and see what do you get. Try to do this until you get 1 inch. It should be like, it should not be 0.98. Try to check on until this, and that's how you're figuring out the domain. So believe it in yourself. You can also check with the Desmos. Just if I type in desmos.com calculator and put that same equation n equals 80 and all that, and see what does that 80 basically in the beginning y-intercept, that's where it starts. And then I can just write here maybe, okay, so n equals 1. No, make a table. I think I can make a table out of this. So let's put a table here. Click here and make a table. And I'm putting minus 1, see, and 0, 1, 2, and then I put 3, 4, 5, 6, 7, 8, 9, and then 10. I think I made a mistake. It's okay, it should be 10, 11, 12, 13, 14, 15, and 16. You will see until 15 is a domain is nice. You can have n cuts, and there will be at least 1 inch, but the moment you go 16 cut, you become a fraction. So the domain could be n equals 1 until 15. So you can write this as, let me see if I can take, so what all you do is the domain is n is between 1 and, sorry, 1 less than equal to n less than equal to. So this is a reasonable domain, or the inputs, how many times you can cut off that 1/4 every time we break this into 4 parts. I hope that. Yes, now let's see question number 4. Here is a recursive definition. So if we are being told that you are being already given the recursive definition. Question is, can we make a table out of this? Yes. So the first thing is, either you can do vertical, or the first one is the very first term is 35. So that's n is the step number. F of n is the number at the step n. Now, what does this means? The one before. So everything starts with 35. So the moment you get 35, look up for what is either added or subtracted, or maybe multiplied. In this case, you can see you take off 8. So if you take off 8, what is left is from 35 will be 20, 27. So the second is 27. And likewise, you can do it and take off another 20, another 8, and that will be 90. And take another 8, and you get 11. So what I'm trying to say, what you're supposed to do is graph this. So 1 is 35. So this 1 is 35. So somewhere here, this will be 1 is 35. So list. So you're going to list. That's what they're asking you. You're supposed to. Best is the make a table the way I showed. So this is the D, which is the rate of change, common difference, and graph this. So and you're supposed to graph this. So 2 is 27. So this is now 27. This is 25, and that is 30. So 27 will be somewhere maybe here, and I want you to do the rest of the part I want you to do. But also from here, can I write the nth equation or nth term? So because this is starts for 1, and I'll say, okay, f of n equals, the first one is 35, so I say 35, and every time after that, plus the common difference is that minus 8, so you write minus 8 is, and then you put n minus 1, and n greater than or equal to 1. So basically you have to write in a nice way, and that is 35 minus 8. Remember, this is multiplication, and then n minus 1, and you're done. But the thing is, if this was started with a 0, how this thing will change? So you write f of n 35, that's where it starts, and you just write 8n, and that's the easiest way to do. So this time you'll say it is start with 1, so there is a 1 here. Because now I said it is 0, then you'll have to say, okay, start with 0, 1, 2, and so on. So n greater than equal to 0, and that's the beautiful nth term, nth equation, or how many times did I not say this? So I hope for the test you'll be doing good. Let's go to the fourth question. Okay, this is question number 5. Here is a graph. So they did give us the graph of the sequence Qn, and we need to find a recursive definition. So what I'll do is n and Qn, right? So the first one, if you see, the first one is down, which is I think it is -3, right? So that part is -3. 3, then 4, and then let's see, the next one is 2. This number is at 0. That means this is 2, 0, right? This is 1 and -3. So 2 is 0. Then this, when it is 1, it is, I think it is 3. And it is 4, it goes on 5. I think the first one is -2. So be careful there. So this is -2. This is -2. And it goes down to 2. And okay, the first one was, again, I made a mistake here. This should be, I was right. So let me take this out. So this number is, because this is 0, so this is -3. This number is 1 and -3. This number is 2 is 0. This number is 3 is 3. So every time you see it starts with -3, and you go on in adding +3, +3, +3, which will be 6. So this is 4 is 6, and this is 5 is 9. So the question is write so this is common difference. To write the recursive, what all you need is the first number, which is -3. So that's the A part. That's the A. It is also written as Q1. So when you are writing the recursive definition, you say, okay, the number at any position is, the sequence is the one before n minus 1, and then you are adding the common difference, which is 3, and then you say n greater than equal to 2, because you always define the first one as -3. So when you write, this is the main thing. You could even write this here, or you could also write this in the beginning right here, saying, okay, the first number in the sequence is -3, and then you say the number at any position is always the number in the previous position and plus 3. So let's do the next one. Okay, this is question number 6, and here is a recursive definition. So they did give us the first one, f of 0. So if you make a table here with the 0, that's 19, and because it is n and fn, I'll put it like this. And then they give us the recursive definition, which says f of n is f of n, the previous one, and you reduce every time you reduce by 6 or decrease by 6. So if I want to go to the next one, and then you decrease by 6, so you're reducing it by 6 will be 13. And then again you reduce by 6 will be 7, and again you reduce by 6 will be 1, and minus 5. So the question explains how you know this definition represents the same sequence. This definition represents the, oh, they give us two different, there's another one. So this is for the first one, and then there's another one. So this part is written in the, this is called explicit formula. You can always call it like a nth equation. You can also call it n term. And now if I want to use this way, then I have to have a table again like this. So, and it says, what this means, it starts with n equals 0. So you put n equals 0 here. So both give you the same thing like 0, 1, 2, 3, 4, and so on. And I write f of 0 here. So it is, if I write f of 0, you get 19 minus 6 times 0, you get 19. So it's the same 19 which is here. If I put 1, then it equals 19. So now I'm putting n is 1. 19 stays the same and multiply by 1. And that also gives you 3. So the question is, why? Explain how do you know they represent the same sequence? It's because when you use this n equals 0 for the second one, you can see you get the same sequence. It's just 13 and then 7, 1. And then if you use this one, you get the same. So they represent the same sequence. Select what is f of 20. All you do here is you have to find of f of 20 is the best is the explicit equation. So this is the better one. This is better because you just have to put the value f of n equals 19 minus 6, and you just say okay, f of 20, plug in n equals 20, and you say 6 times 20, and you get the answer. So I hope that helps. That's almost now 28 minutes. I'll try to do that. I'll skip the last one for you to do, okay? So you do 7 problem. So thank you for watching. I only hope this will help. For many of you, especially when I'm teaching in the class, become difficult. But here I'm just putting across everything that comes in my mind. What's the difference between recursive definition and explicit formula? So that's the goal here. When do we use? Look at this. This suddenly gave you the nth definition, the recursive definition. This one say n greater than equal to 1. That's because you are taking care of 0. See, that's taken care right here, f of 0. So I just want to show uh, f of 0. Thank you. Then I'll do the next video for lesson number 10.